class, welcome to our channel Leaders Academy 5074. Today we are looking at the topic differentiation from first principle. It is some topic of differentiation class from calculus, and I believe we have prior information, or should I say knowledge of graph, and we know that this is what the vertical axis of a graph is known as what, the y-axis, and this is what, x-axis. Now, with the idea of slope means what? Slope means change in what? Change in y over change in x. Therefore, from here, I have that if I plot a graph and say this is the what? This is the y1 value, and this is the what? y2 value. I would also have that this is my change in y, and this is my what? My change in x. Are we there? Change in y and change in x. So I can say also that y, remember that y is a what? A function of x. Y is a function of x. That means we are getting the values of y because y is dependent on x. So x is an independent variable while y is a dependent variable on x. So with this now, I have that my function of x is here, function of x or y, function of x, and this is my what? This is my x1 and this is my what? x2. Right? Now we also have to analyze this. That if we are using the Leibniz notation for change in y over change in x, which is dy dx, we'll be having that this is our dy and this is our what? dx. Now, if this is the function of x to this point, what do you think will be the function of x from here to here as regards y2? Because there's an addition. It's not just this now. There's an addition. That change, that addition there now will give us what? It will give us what? Function. As regards function, now function of what? X plus dx. So from here to here is function of dx. While from here to here is known as what? Function of x. Are we following? Now, back to our getting first principle. We want to know how to derive first principle. If we have a question, how we can solve it and get our answers. So we have here now that the y, the x is equals to limit as the x tends to 0 of f of x plus dx minus f of x all over dx. So this is what we need to solve questions on what? On first principle. This is what we need to solve questions. Now let us take an example. Example, let me say I'm asked to differentiate from first principle x squared. Differentiate from first principle x squared. So to differentiate from first principle x squared, I have what? This is what I want to differentiate from first principle. F of 1 of x, in this case now is what? X squared. Differentiating from first principle. In the previous class I told you about having this sign. This also means what? My dx of what? X squared. That means I'm differentiating from first principle of this value now, x squared. What will I do? Now, the first thing, I'll come here and take the whole of this. I'll say what? The y dx is equal to limit as the x tends to what? 0. Limit as the x tends to 0 of what? Now the first thing I look at x plus dx. Instead of x plus dx here, now I have the function now is what? X plus dx all square minus, what is my main function that I'm differentiating? What I'm differentiating is what? Is x square. That's what I'm differentiating, x square. So I have all over what? dx. Somebody follow. Now the next thing, I need to expand this. When I expand that, you know that from our basic mathematics, formula factorization, we were taught how to expand. So what we do here, I have what? X square plus 2x dx plus dx square minus x square all over what? Dx. Now you can see that we have something here that look alike, right? We have this thing that look alike there. So they're going to subtract themselves because it's x square and this is what? X square. X square minus x square is gone. So we have limit as the x tends to 0 of the whole of this. Limit as the x tends to 0 of the whole of that. So we have also that our answer here now is 2x dx plus dx square all over dx. Now I can what? Factor out and have dx 2x plus dx over dx. This dx will cancel this and everything will be in what? As limit as the x tends to 0. So limit as the x tends to 0 of 2x plus dx. What do we say? As the x tends to 0, as the x tends to 0, what happens? The x becomes 0. Therefore, our answer now is what? This guy becomes 0. Our answer now is what? 2x. Our answer is what? 2x. Now let us just test this using our general rule. Remember in the previous class we talked about general rule. So we have, I'm testing using the general rule now. So for general rule we have y equals to f of x, then the dy dx will be equal to what? ax is to the power n. So looking for the dy dx of this now, I have an x is to the power n minus 1, right? If this is this equal to this, so looking for the differential of it, we have this times this give you the answer minus 1. So in this case we are dealing with x squared, as our question is x squared. So we have d dy dx of this is equal to what? Differentiating that, you have x squared, this times 1 is give you what? 2. So x is to the power what? X is to the power what? 2 minus 1. So at the end our answer is what? 2x, because I've differentiated what? I've differentiated this guy. Give me 2x. So if you watched the previous class, you'll be able to understand what we did here. Our class on what? Our class on differentiation using the general rule. So thank you very much for watching. And if you have any questions, any comments, you can do well to use the comment section. Please like, share, and subscribe to our channel. And may God bless you. Thank you very much.